On this episode of the podcast, I have with me Brian Young. He is the Director of Engineering at Grindr. We're going to be talking about dealing with scale and tech debt. So obviously scale is very important. You hear a lot of companies talk about scale. They need to get to a certain size and scale. That's actually great. I'm glad that everyone's trying to achieve more, but do we always need that scale? And Brian's going to talk to us about what scale means. Do we need to actually focus on it? What's the impact of actually going after scale when we don't need it? And also tech debt. Does it kind of slide into this conversation of some of those decisions made along the path of trying to quote unquote scale? Brian, thanks for being on the show. I appreciate it.
Yeah, very happy to be here. Thanks for having me.
Awesome. All right, before we dive in, I'm not going to assume everyone knows Grindr. So if you could just give everyone just a 64,000 view of what the company does before we dive in, that'd be great.
Absolutely. Grindr is the largest social networking app and dating app for the LGBTQIA plus community.
All right. Well, let's get into this, because obviously when we were first talking about what to talk about, you mentioned this, and I was like, "Ooh, this is definitely a good one," and I was excited about it. In your background, we'll obviously out there, and people can find you on LinkedIn. You've worked for some fantastic companies along the way. You've seen scale of different size and dimensions. Maybe let's go back a step and actually talk about what scale is and what it means, because I think it's a moving target depending on who you talk to and the person's experience and lens. When you hear the term operating at scale, does that mean something different for everybody?
It absolutely means something different for everybody. I think in general, operating at scale is designing your software application in a way that is able to meet the traffic needs for your user base or the usage for that system. Obviously, when you talk about at scale, that's relative depending on where you are or who your customer base is, or whether you're spread throughout the world or only localized. And you mentioned before Grindr, I had a long career. I've been in the industry for 25 years. Most immediately before Grindr, I was at Wayfair, and before that was at Amazon. And so obviously designing for scale at companies like that looks a lot different than it does at than designing for a startup. So when I was at Amazon, scale was obviously critical. I managed an engineering team on the back end of the retail website, whose service needed to handle more than 20 million requests per second on peak days, which when you're talking about designing at scale, the scale probably doesn't get larger than that anywhere in the world. And, so in that situation, anytime you're looking at scale, you start kind of looking at the CAP theorem. I don't know if you're familiar with that, but it basically says that, you have three components: consistency, availability, and partition tolerance. And you can maximize or solve for two of those, but not the third. And so when you're thinking about scale, you have to decide where to make that trade-off. And so, at Amazon, on the back end of the retail website, specifically at that very high scale, in that situation, availability and partition tolerance are critical because the retail website obviously can't go down. If it goes down, we're losing millions of dollars. It's a big problem. The system needs to continue to function if communication between certain nodes in your network are lost. And so partition intolerance is important. And so the area we traded off or flexed on was the area of consistency. And so, due to that, we built the system in a way that we had a big pre-compute workflow where a lot of the complex computation was being done ahead of time. And then we had multi-layer cache that cached that data. And because of that, the data could be inconsistent for up to 15 minutes. So, for example, if you update the price of an item on Amazon, not all users are going to see that price immediately. Some of the users will continue to see the old price for up to 15 minutes while that change propagates through the pre-compute flow and the cache TTLs have time to expire. And so we're in a system where it's important that we always serve a response, but it's not important that that response necessarily always gets the same data for every customer. And so the system is designed in a way that it's eventually consistent, but it does not have a firm consistency. And so that's just one way that you can design at scale. And now I'm at Grindr, the largest social networking app for the LGBTQ plus community. We have over 13 million active users. So obviously it's important for us to design at scale as well, but it's orders of magnitude lower scale than what I was doing at Amazon. And so, 13 million users, obviously it's important for us to be flexible. We have some times that are peak times. And so we design, a cloud-based microservices architecture that allows us to scale horizontally by easily adding new nodes. And that allows us to scale when we have peak traffic, but at our baseline traffic, where we have normal load, we can scale back down so we're not spending more than we need to on infrastructure costs. And so that's kind of what scale looks like at Grindr, which is still, I would call, at scale or high scale, but not nearly as high scale as Amazon was. And if you're looking like a startup where you're just getting started, scale means something different entirely.
Yeah, it's interesting. As you're kind of talking, sometimes when you hear this concept of scale and you talk to an engineer, it sounds like a lot of technical components go into it, a lot of science, but also in listening to you, there's a little bit of art that goes into it. And maybe I'm wrong. I mean, you can correct me, but is there a hard and fast rule? Is it experience? Is it understanding the future growth and trying to anticipate? When we're talking about scale, that balance of art and science, where does one tend to kind of lean?
Yeah, a lot of it is an art and understanding where you're at and what your need is now, and also where you're going in the future. So, not every business is the same. There's a software design concept called YAGNI, or you ain't gonna need it. And this is a principle where, you design for the known knowns, the things that you know today. As engineers, we kind of have a tendency to over-design things. We like to understand every possible permutation and every possible use case and scenario, and try to cover all those edge cases, no matter how unlikely they are. And our engineering minds like to do that. We like to be problem solvers. But it doesn't really make sense to do that in the real world because this YAGNI concept tells us that we want to design for like the 80% use case. We want to design for those main critical flows, and other cases may not even manifest down the road. So if we spend time and money trying to solve for those cases and they never come up, that time and money is wasted. And so, we can solve for that 80% use case, get something out in the world, start collecting real data from users using it, understand what their usage patterns are. And oftentimes you'll find that they are not even using it in the way you expect. They'll use it in completely different ways. Their edge cases will be different than what you expected they would be. And now you can actually get that data and find what the real edge cases are that users are actually hitting. And then you can iteratively improve that application and, grow and design for the scale and the usage that you're actually seeing.
That's actually, that's fantastic. And I think, you use the Amazon example, and maybe we can take a small step back and kind of reflect on that time. And you mentioned a little bit of art, more art than science. You can over design, and you can overestimate, you could underestimate, you could do all these things. I guess as you're kind of thinking through dealing with scale, and you're thinking about, I'm anticipating slight amounts of growth, you're making decisions at point in time. And then obviously, hopefully your company's growing. Not always, but hopefully the company's growing and you're seeing the positive fruits of your labor, and you then have to go back and look at what you've done. This notion of looking back and going, what were the decisions made? Okay, well, this person's not here anymore. Why did they make this decision? Because at the time, it could have been the right fit for the right time at that juncture company, but now we have to go back and redesign, re-architect. And this notion of technical debt comes about where we have to go back and look at that. is that, I know we talk about technical debt as in, it has a negative connotation, but should we maybe talk about it as, hey, it's okay. These are just decisions made in the past. You can't control them. The business grew. These aren't actually necessarily bad problems. They're not fun problems because engineers like solving new problems. We don't want to go back and resolve problems that we think were put to bed. But I mean, talk to me a little bit about that.
Yeah, I think there's a lot of truth to that. Technical debt is really, the artifacts left over from the decisions that we made. Those decisions and the usage patterns aren't always what we expect. And so, and like you said, people leave. We may not even understand why a decision was made. But, I always like to believe that people made the right decision at the time based on the circumstances. And, I kind of like to give people the benefit of the doubt that even when we're in a mess and you're like, why did they design this that way? That, they did it for a good reason at the time. And as we look going forward, I think it makes a lot more sense to look forward and instead of looking back and trying to opine on why someone made a certain decision in the past, but instead we want to look at what the growth is projected in the next 1 to 3 years. Where are we going, and what are the gaps between where our system is now and where it needs to be to meet that need 3 years from now. And what should we be doing now to make sure that we're prepared, when that growth comes? And so, I think tech debt and scale are related in a lot of ways. And, when we're designing something, we always intentionally make trade-offs. And, a lot of those are based on resource constraints. We may not have enough engineers. We may not have enough time. We have product and business requirements of things that we need to do to solve problems for our customers. And we make trade-offs and say, these are the things we're going to prioritize, knowing that in some cases we're intentionally taking shortcuts, fully intending to go back and fix that thing later. But, based on experience, I know most of the time you never really go back and do that. And so, I think in some cases, the amount of technical debt you think you have is kind of a myth. And, what you really have is business problems that need to be solved and an approach of how you solve them. And in a lot of cases, it's just, more important to how do we solve those future problems, and how do we get stuff done to solve those business problems instead of going back and consistently like rethinking and reevaluating what we should have done in the past. I don't think that's usually a helpful exercise.
I love the way you put that. And maybe we'll unpack one or two things in that you said, because I do, when we first talked about the subject, I was like, oh, I love this, because I think the two are related. And I think a lot of it has to do with decisions in the past, because I think scale is also a component of scale at the point in time the decisions were made. And I guess as the company's growing, they hire different types of people, right? So Amazon 2002 would have hired a different engineer than Amazon 2024, potentially, right? Solving different problems, different skill sets. I think something that doesn't get talked about a lot is a company that's 0 to 100 in size is going to hire certain people. They have skill sets to solve certain problems. They might have solved the problem appropriately for the company at that stage at the time. Once they're 5X and the next set of engineers come in and they're looking back, they're like, I would have never done this way. Now, we could talk about, well, there's different, skill level to engineering. We could talk about that. They have different experiences. You can chop up this thing different ways. But I think a lot has to be said to that person was brought in to stand up certain things for business decisions. And really the big problem is somebody's coming in having to fix something that's on now a moving train, hopefully a fast moving train. And that's hard. And I think that's really where the rub of technical debt comes in, is you're telling me this thing is making money. You want me to replace it mid-flight, and you don't want to lose a beat, or you don't want it to be too expensive. I think a lot of what's happening is somewhere in this depth. And I guess maybe get your thoughts on both those aspects. One of, engineers might have different skill levels. I mean, something we need to consider given the time and place of the company. And secondly, it's actually the problem the person coming in trying to fix this, not necessarily a bad thing, but it's just a new business problem.
Yeah, I mean, that's absolutely the case for a lot of reasons. At a startup, you're going to hire engineers that index on really getting things done. And the other thing to note is typically startups don't have as much money, right? And so they're not going to be able to, hire an engineer that's worked for Amazon or Google for 10 years. They're going to get the best engineer they can for the money that they have to spend. And that person's probably not going to be as experienced. They're going to build the best solution that they know how with what they have and with their level of expertise. And, that may not be the most scalable or modifiable solution in the long term. And 5 years down the road, especially if that company's grown, the company's probably going to outgrow that person's skill set. Hopefully they've grown a little bit with the company, but they may not have the knowledge or the experience to be able to modify something that fast moving train mid-flight and understand the potential impact of making certain decisions. And I think this has got a little bit better the way that we've moved to the cloud world, where people aren't necessarily like owning their own bare metal infrastructure anymore. They're spinning things up on the cloud. They're easier to spin up, spin down, easier to scale out. But it also kind of creates a problem where people don't really understand what's going on at that infrastructure level. And infrastructure as code is a big thing now. And, people maybe don't understand that they're building something that doesn't scale well. And when they do, now need to scale horizontally, it becomes incredibly expensive because it wasn't designed right in the first place. And so I think that's where you really get a problem coming, where, TechNet debt and scale don't match. And when you get in that situation, you really oftentimes need to go and do a re-architecture and say, how can I actually more efficiently use these cloud resources in a way that is going to be cost efficient, as well as, solve the business problems that we're trying to solve for.
Yeah, I mean, it's funny as I listen to you speak about this topic, I'm thinking a lot about context. And heck, I can't remember. Sometimes my wife goes, "Why'd you make this decision?" I go, "I don't remember last week why I said that, but it must have been some good reason. I can't remember the context of why we said X, Y, or Z a month ago, a year ago." And I think a lot of this context that we talk about is very difficult to capture. I know we're commenting, we're leaving coding manuals in GitHub, we're doing all this stuff to make sure that we have context. It seems like that is a bottleneck. It seems like that is a problem that could be solved. And obviously we can't record every decision being made. We can't, no one's going to sit through and listen through that much documentation. But is this a potential problem that could be solved if we could re-envision how context is captured for software engineering? Is that a thing, or is this just a preposterous notion of context can't be captured?
I mean, context can be captured for a snapshot in time, right? But things change, code evolves. Engineers are notoriously bad at updating that documentation. And so I've kind of taken the view that the code is the documentation. Like, people don't update the Confluence docs and wikis. People don't update the comments in the code. They get outdated very quickly, and it's very easy to lose context. And so the only real source of truth is the actual production code that's running now. And so it does not give you historical context. You don't have the metadata around the how and why. You only have the what is, but that's really like the only firm source of truth that you have.
And I guess to kind of continue with that, technology, if we look back in the last 15 years of development, I mean, you've gone through some, working for some different companies, different experiences, and you're approaching, Grindr with all those tools in your toolbox, even if we did have context and you could look back and go why this decision was made, might that be irrelevant? Might it be a case of technology is evolving so that the lifespan of code itself, regardless of context, coding, documentation, and wikis, there is a lifespan. Once we hit a certain point, obviously somebody out there is going to be like, hey, listen, I'm supporting COBOL code from 50 years ago. You have no idea what you're talking about, which might be true. But it's just the fact that technology is evolving and we're starting to see different tools even now that we saw 2-3 years ago with some of these co-piloting tools. Does that put a little bit of a different burden on this notion of tech debt and how it's been looked at?
I think it does. Context, I think, would still be very helpful in a lot of situations, especially when you have a critical incident and you've got newer engineers that don't know the history of the code base. But a lot of times, like I said, it's just not there, and so you just have to kind of reverse engineer the code and do the best you can. But yeah, I think it's interesting with a lot of these tools coming out, Copilot, ChatGPT, it's a very fascinating technology that I think will transform the industry. But it's really in its infancy, and the quality of what it can do right now just isn't really high yet. It's maybe can help you give the output that you would get from like a college intern at best. It is getting better. It will get better over time. I've been looking at some initiatives, like there's an open source, AI coding assistant called Devika, and a company called Devon that started based off of that project that's, trying to build, basically like AI software engineers. And, I think with those projects in flight, they'll get better. I mean, right now they're just not there. They're not in a place where they can add that much value. But they will get there over time, and I think that will become maybe at least a partial solution to a lot of these tech debt issues. Fixing bugs. Certainly, they're already valuable in tasks like writing unit tests, and things like that. And so, I think that's part of the solution now. It will become more of the solution in the future, but it is kind of an evolving technology.
Absolutely. Well, Brian, I know you got to get back to the day job and tackle what we're dealing with, probably at some scale level. But I really appreciate your time. Thank you for sharing. I think we're never going to exhaust this topic. I think we need to do maybe a roundtable discussion about this and include you, because I do think this is something that is interesting when we start talking about these components that are difficult in context. Keep going back to that word, because I think you made a great point of that. So I appreciate your time. If somebody's going to have a question, since we did not obviously exhaust the topic, and they want to reach out to you to talk to you about scale or some of this tech debt concepts, what's a good way of connecting with you?
Yeah, connect with me on LinkedIn. Like I'm happy to connect with folks there, answer questions. If they have follow-ups, I'm happy to take those.
Absolutely. We'll do. We'll put those in the show notes. And again, thank you for your time. I appreciate it.
Awesome. Thank you so much. Thanks for having me.
Absolutely. That's it for the episode. Be back again, different guest, different topic. Until then, two things. One, I thought this was a great, honestly, podcast episode when Brian proposed, scale, and we talked about tech debt. I was like, this is fantastic. We haven't talked about it in this relation before. And I think his background, his experience was great in the conversation. So please just share this with somebody else who might find it interesting. I appreciate that. Also, like, subscribe, comment, let me know how the podcast is going for you. Until next time, thank you and goodbye.